Hello everyone, today we are going to look at differentiation and we are going to start with first principle method. So let's look at the way it is, because when, for instance, if you have a polynomial y is equals to x raised to the power of n, then the differential of this, that is the derivative of this, is going to be dy by dx is equals to n x raised to the power of n minus 1. So today we are going to see how we can be able to prove this using first principle. So since we already assign y to be equals to x raised to the power of n, so we can see y plus delta y is equals to x plus delta x, all of them raised to the power of n. So, and this y plus delta y is equals to this one. When you expand it, you are going to get summation from r is equals to 0 to n of n combination r, then x raised to the power of x raised to the power of n minus r, then delta x raised to the power of r. So this stuff, what's the meaning? So let's look at it. We can be able to expand that plus delta y is equals to, then summation. When we are to expand, we are going to have, let's expand the first two terms in the summation. So the first one, we are going to have n combination 0, then x raised to the power of n minus 0, then delta x raised to the power of 0 plus n combination 1, then x raised to the power of n minus 1, then delta x raised to the power of delta x raised to the power of 1, then plus, this space is not going to be enough, let's say plus, then you say summation from r is supposed to, we finish with 0 1, then the next one is 2 to n, then n combination r, then x raised to the power of n minus r, then delta x raised to the power of r. So when you look at it, what is the meaning of this n combination 0? So this n combination 0, it means n factorial all over 0 factorial, then n minus 0, all of them factorial, based on the formula of factorial. So then this n factorial, this 0 factorial means 1. So we have n factorial all over, n minus 0 is n factorial again, and n factorial is 1. So when you multiply this one by 1, you are going to get n factorial over n factorial. So this n factorial over n factorial is going to give you 1. But what of n combination 1? So n combination 1, we have n factorial all over 1 factorial, then n minus 1 factorial. So then this is going to be 1 factorial is just 1, so n factorial all over n minus 1, all of them factorial. So an n factorial can be represented by n into n minus 1 factorial all over n minus 1 factorial. So, and this one will cancel this one, so n combination 1 is equals to then n. So we have the expansion of the first two terms, so our equation becomes y is equals to y plus delta y is equals to, then the first term we are going to have, since all this term becomes 1, then this one we have n x raised to the power of n, so we have x raised to the power of n, because n minus 0 is n. Then delta x raised to the power of 0 is 1. When you multiply by this, they all vanish again. So plus, then here n combination 1, we obtain it as n. So we have n into then x raised to the power of n minus 1, then delta x raised to the power of 1 is the same thing as delta x raised to the power of 1 is the same thing as delta x, then plus, then summation from r equals to 2 to n of n combination r, then x raised to the power of n minus r, then delta x raised to the power of r. So from this place, we can, since we are looking for delta x, this is why we crosses equality sign, and we already know that from the beginning that y is equals to x raised to the power of n. So since y is equals to x raised to the power of n, so when it crosses equality sign, it becomes minus y. So we are going to have y plus we are substituting, so delta y is equals to y, which is, let's put the value of y as we have x raised to the power of n minus value of y x raised to the power of n, so then plus n x raised to the power of n minus 1, then delta x plus summation from r equals to 2 to n of n combination r, x raised to the power of n minus r, then delta x raised to the power of r. So, and from this place, these two will cancel, so we are going to be left with delta y is equals to n x raised to the power of n minus 1, then delta x plus summation from r equals to 2 to n of n combination r, then x raised to the power of n minus r, then delta x raised to the power of r. So you can be able, since each term contains delta x, so you can be able to factor delta x. So we have delta y is equals to, we can factor delta x into delta x into x minus 1 here, n else minus 1 raised to the power of n minus 1, then plus, then summation from r equals to 2 to n of n combination r, then x raised to the power of n minus r, then when you subtract 1 here, you have delta x raised to the power of r minus 1. So that is, you factor delta x from each term, from this term and from this term. So the next thing, we are going to divide through by delta x. So when you divide through, we have delta y over delta x is equals to delta x all over delta x into n x raised to the power of n minus 1 plus summation from r equals to 2 to n of n combination r, then x raised to the power of n minus r, then delta x raised to the power of r minus 1. So, and this one becomes 1. This one will cancel out, they become 1. So the next word we are going to be left with is delta y over delta x is equals to n x raised to the power of n minus 1, plus summation from r equals to 2 to n of x n combination r, then x raised to the power of n minus r delta x raised to the power of r minus 1. So when we take the limit as delta x approaches 0, this means that delta y all over delta x will approaches dy by dx. So when we take it as this, we are going to have dy by dx is equals to then n raised to the power of x nx raised to the power of n minus 1 plus summation from r is equals to 2 to n of n combination r x raised to the power of n minus r, then 0 raised to the power of r minus 1. So 0 raised to the power of anything is just still 0. So and 0, when you multiply any time by 0, then it will vanish. Then we are going to be left with, we put 0 here because the limit as this limit delta x approaches 0. So you remove delta x and you substitute the value of delta x, which is 0. So it will vanish. This time will just go. So we are going to be left with dy by dx is equals to nx raised to the power of n minus 1. So this is a way to prove it, and I believe this is a very simple proof. And if you like this video, you can please subscribe to our channel and you turn on the notifications so that you can be able to see our next video on time. And if you have any question or suggestion, you can leave it as a comment on this video. Thank you.